You selected answer A for this problem, which is not correct, and so it will not stay at 35%. And to see why, it's helpful to look at a solution to this problem graphically. So what I'm going to do is construct a plot of conversion that we achieve as a function of temperature. And here we expect that the conversion is going to depend on temperature in this adiabatic system. Now, for an exothermic reaction, we expect that the equilibrium conversion, which is the maximum conversion that we can achieve for a reversible reaction, is going to decrease as we increase the temperature. Since heat is a product of the reaction, increasing the temperature lowers the amount of conversion that we can achieve. And we can show that qualitatively like this. In the initial reactor scenario, we have a feed temperature of 400 Kelvin, and we expect that as the fluid goes through the reactor and continues to convert from reactants to products, since the reaction is exothermic, the temperature is going to go up as we get higher and higher conversion until we get to 40% conversion. And that 40% conversion was achieved regardless of the flow rate, so whether we had a fast flow rate or a slow flow rate. So in other words, whether we had a short amount of time in the reactor or a much longer amount of time in the reactor, we got to the same conversion. And that indicates that we've reached the equilibrium limitation of that reaction, that allowing the reaction to proceed for a longer period of time doesn't allow us to get to higher conversion. All right, so we therefore are equilibrium limited. We next need to consider what happens if we go to a different reactor temperature of 350 Kelvin for the inlet. Now what we see is that we can ultimately be limited, but we don't expect that as that temperature increases, it should increase at about the same rate if the heat capacity of the fluid isn't that different. We're not going to be limited to the same conversion, and so we're told that initially we get to a conversion of 35% at a fast flow rate. We don't expect that if we allow more time for the fluid to react inside the reactor by having a longer space-time for the reaction, that we're going to be stuck at 35% because we can continue moving to higher temperature and higher conversion. And for this reason, selection A is not correct.